We learned from a friend recently about a program they've got at the Mississippi State Extension Service called the Native Plant Producer Network, in which they're trying to get homeowners and organizations to grow the plants needed for salt marsh restoration in Mississippi. The salt marshes around here are dominated by two species of plants, Spartina alterniflora and Juncus roemerianus, and there really isn't a commercial grower between, say, South Florida and Texas that produces these species at a scale large enough to use in these restoration projects. A typical project could require anywhere from a few thousand to tens of thousands of each species. So they need a lot of them, and the only way they can really get it right now is to try to crowdsource it and get more and more people to grow them at their house. It's really not that difficult to grow them, as I'm going to show you in this video, but the more people they can get to do it, then obviously the more plants they'll have for these projects, which are increasing in number year by year. So it's pretty important that they get enough plants to do these restoration projects, because these grasses are essential for protecting our shorelines, providing habitat for native wildlife, and so on. But we'll get into all that in a minute. First, let me tell you a little bit about each species, because it's interesting how they work ecologically. So let's start with Spartina alterniflora. This is a relatively short-lived perennial grass that reaches about 5 feet in height at the maximum. It grows at the very edge of the marsh, meaning the water's edge, not the land side. Wikipedia calls it an environmental engineer, which I thought was a pretty cool term. And the reason it's called that is because it goes out so far to where no other plants can, and then its stems serve to trap sediment as the waves bring it in, and it slows down the waves, and that causes the sediment to fall. And over time, that builds up the soil, the ground under the water. And when that happens, it allows other species like mussels and stuff like that to come in and set up shop. And that in turn causes the land to build up more and more. And as the land increases under the water, more species, different species of plants are able to come in and start growing. When that happens, this goes even further out. It just keeps, it's kind of like it's pushing the edge of the marsh out. So in that way, it's kind of like an engineer in that it's building the infrastructure for other species to come in and live. So it's very important for that reason. But because it lives so far out toward the water side of the marsh, it can't handle very, very high salinity. See, I guess if you think about it, the water is saline. Well, it's kind of brackish here. I guess it depends on the rainfall. But as the water is pushed up into the marsh farther and farther, the salt gets trapped, right? And it accumulates higher up in the marsh. So the plants that are farther up in the marsh can handle more saline conditions, but this one grows out on the edge. So it's less tolerant of salt than the other species we're going to look at in a second, but that's not its role, is to handle salt. Its role is to build up the land, and it's extremely important for that. It's a buffer for waves. Like I said, when waves hit it, it slows them down. So when you have storm surges or from tropical storms or any kind of storm that's pushing waves up, it's buffering against that. It's very, very, very useful plant. Unfortunately, it's so useful that humans have tried to export it to places like England and China, and it's become a very big invasive problem over in those places because it is such a good engineer and it can outcompete a lot of the native plants, marsh plants. I think I read that in England, it actually hybridized with their native Spartina species to create a new Spartina species, a hybrid that's extremely damaging ecologically. So it's one of those things where it works great where it's from, but you might not want to try to export that functionality to a different location because you can't predict what's going to happen. But anyway, this is the first of the two species that the Native Plant Producer Network is getting people to grow. So let's look at the other one now. So this is the other species that we're growing through the program, Juncus roemerianus, and it's quite different from the Spartina we just looked at, both in terms of its physical properties and its function within the ecosystem. Whereas the Spartina grows on the waterside edge of the marsh and continuously pushes the marsh out horizontally, the Juncus grows in the high marsh, the part closer to the land, and it builds the marsh up vertically. It does that because it creates these really, really dense root mats that eventually turn into peat, and that peat lasts for centuries and it keeps the high marsh high. It's basically a bridge between the land and the water in terms of species as well. Like you'll have the land plants that can't handle any flooding, then you'll have the Juncus, which can handle some flooding, and then you have the Spartina, which can be in pretty much completely anoxic conditions underwater 24/7, more or less. And the species that live in and among the Juncus are different than those that live in and among the Spartina. Like the Spartina, you'll find shrimp, crustaceans, little fish and stuff like that living in them, whereas the Juncus is more insects and like spiders and stuff like that that can't really be underwater. Now, the Juncus is very like hard and needle-like. You can actually stab yourself in the eye with these things. That's why its common name is what it is, but it's much more long-lasting. Like I said, the Spartina is more of a short-lived perennial. The Juncus stands can last for many decades. One interesting thing about this Juncus roemerianus is that within a given population of it, the plants that are closest to the shore, closest to the land side, which are in the most saline conditions, will be slightly different genetically than the plants that are closest to the water's edge, which is less saline. It's kind of stratified because they have to be able to handle different levels of salt, and for some reason the ones that can handle the most salt are dwarf. They don't grow as tall. I'm not exactly sure why that ended up happening, but if you look at a marsh, the taller Juncus will be closer out to the water, and the ones closest to the land, which can handle the most salty conditions, will be shorter. I thought that was pretty cool. But this is an extremely important plant structurally for salt marshes. It's not like it's endangered. I mean, it's super common, but the problem is because it's so common in a salt marsh, if you want to restore a shoreline of salt marsh or a salt marsh in general, then you need a ton of this plant. And that's why the producer network is trying to get people to grow it, because you just really can't get enough of it to do restoration projects here in Mississippi. And as I said earlier, they're doing more and more of these restoration projects every year as people realize that a salt marsh coastline is much better in many ways than building a bulkhead, both in terms of long-term stability, erosion control, cost. I mean, there's so many benefits to having what they call a living shoreline with basically marsh grass, how it is naturally, than trying to build some kind of bulkhead to keep the waves out. That's why they need so many of these plants to do that. One other difference between these species is that the Juncus is more readily propagated from seed. I know that's something else that the program is trying to do to ensure genetic diversity within populations, because if you clone them all from the same plant, they all have exactly the same genetics, and then they're potentially more susceptible to disease and stuff like that. So we're not going to do that here yet. We just want to learn how to grow the plants that we receive and to propagate them through asexual reproduction, division, splitting them up, which I'm going to show you how to do in just a minute. But first, let me tell you briefly about how you could go about growing these, becoming a part of the network if that's something you're interested in. When I heard about this program, I was interested in being a part of it, so I contacted the Mississippi State Extension Center right up the road, and I got in touch with Mrs. Caitlin Mitchell. She's the one in charge of this program. And last week she brought out this. This is what they call a pond. This is one of the ways that they grow them. This is a 2x4 frame. I think it's about 4 feet by 8 feet. And under that is a weed cloth. And into the frame they staple a 10mm liner to hold the water. and then you just put the plants in and fill it up partway with water, and it simulates, you know, a marsh. It's being in the marsh. Now, this is fresh water, obviously, out of the faucet. The thing is, these plants can tolerate salt, but they don't necessarily like it, so they grow just fine in fresh water as well. One thing I'll say about this is I recommend putting it on level ground. This is like a slight slope where it starts to slope down to the bay, and you know, it doesn't seem that much of a slope at first, but when you put the water in it, you see how much it's angled, and the water is going to run all down to one side if it's angled too much. So do the best you can to level the ground before you put it down. I mean, it'd be easy to move if you put it in the wrong place. It's not permanent. You would just have to move the plants out of it and kind of slide it where you want it. You know, it's just a light 2x4 frame. Anybody can move it. But right now we've been focusing on dividing the plants. She had asked me when I went up there and met her at the greenhouse whether we'd be okay with dividing some of the plants, because that's what they really needed at the time. And I said yes, because I did want to learn how to do that. So she brought us a lot of plants that need to be divided, like they're super root bound right now. So Kiyomi and I have been working on that this weekend, trying to get them divided. We're starting to run out of room. I think these ponds hold about 200 plants or so, but if we're dividing some of them into, you know, 3 and 4 different plants from one plant, that's quickly becomes 200 if we started with 100, you know. So next week she's gonna bring us out another frame, and I'm gonna set that up, and she's gonna bring us some more soil because we also ran out of that. I think what I'm gonna do is when I get the other frame, I'm gonna split the species up and put all the Spartina in one and all the Juncus in the other, since they do have maybe slightly different water requirements. I could keep the Juncus more on the drier side, or at least drain it every once in a while so that it can dry out a little bit to simulate the natural environment. Whereas the Spartina, I think it can just be underwater all the time. I don't think it really cares as much about that. So that's just something I was thinking about. But to finish the video, let me show you how we've been dividing them to propagate them asexually. It's not really that difficult or different than any other plant, but it might be useful to see how it works. So let's start with the Juncus. The first thing I've been doing is taking some hand shears and cutting all the roots out of the bottom. Otherwise, you'll never be able to pull the plant out of the pot like that. Get all the roots out as much as you can. And then sometimes you can just pull them out. Sometimes they're kind of stuck. So what I do is I take like this trowel, and you can stick like one of the prongs into the pot like that, right? Then hold the plant and just pull it out. Now, this one, we could probably get 2 out of, like that, 2 plants. So I think I'm gonna split it right down the middle like this. You kind of got to look at them because they all grow differently. So I think I'm gonna go with 2 here. Now, what I've been doing is I have like this tool right here, metal, and I'll just put it where I want to split it, and then I'll hit it with a hammer. Right, split it open. Once you get it mostly split open, you can take the shears and then cut the bottom roots or any kind of roots that are remaining. And now we have 2 plants. Yeah, I don't think I'm gonna split those anymore. So now we can come over here to some soil. I'm actually using some of my soil because I ran out, and she's gonna bring some more, but this will be fine for now. It's like half sand, half compost. It should be okay. And then I've just been putting them like in the middle, like see how it's split? Obviously you don't want to put it on the side really because it's already root bound on that side. So I'm trying to put it in the middle like that, and then just throw the dirt around it. Pack it down in there. Good to go. Now it's really the same thing with the Spartina. See how I gotta cut all these roots off to get it out of there. put this in there. Pull the pot off. Now this one, I know that this part could make a plant. We could try splitting this one into 3. If we go maybe like this. That'll be 1. I think that'll be okay as 1. And then this one, we can probably split again. Like that. Okay. And just pot them up. Okay, let's go put them back in the thing. The water will wick up through the soil, just like when you bottom water a tray of seedlings, so you don't really gotta do anything except put them in there. Well, that's really all I wanted to talk about in this video. If you live on the Mississippi Gulf Coast and you're interested in becoming a part of the Native Plant Producer Network, I'll put the website and other information on the screen and in the description for this video so that you can contact Mrs. Mitchell and figure out how to get it set up at your house. Thanks for watching, and until next time, good luck out there.